So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing Leetcode daily problem of the day. Find eventual safe nodes. And in this problem, we have to given a directed graph of n nodes with each node labeled with 0 to n minus 1. And the graph is represented by 0 index 2D integer array and the graph of I is an integer array of nodes where the adjacent nodes of I and the meaning of the edges from node I to each node is our graph of I. And after that we have to given a nodes of terminal node, and if there are no outgoing edges and a node is a safe node if every possible path starting from the node leads to a terminal node or a safe node. And after that we have to return an array of containing all the safe nodes, and we have to return them into ascending order or a sorted order. And now let's look at their problem statement, and then we have to looking their example test cases and their coding implementation part. And so here we have to given a 2D index integer array of a graph, and we have a given a directed graph, and this directed graph we have to represent a 2D integer array, and each array the graph is labeled with 0 to n minus 1. And a node of I, we have to given a node of I is considered if the safe state if every possible path starting from I this is our starting from I, and eventually we have to lead to terminal nodes or another safe node, and we have to given a terminal nodes is one that no outgoing edges from going their node, and this is our terminal nodes. And also our task is to identify all safe nodes in the graph and return them into ascending order. And so our goal is to find all nodes that are safe, and we have to return them in sorted order. This is our goal. And so now what is our approach to identify how many safe nodes are present and how we track these values. So first we have to reversing the graph, and after reverse we have to work with original graph and reverse the direction of each edges to calculate incoming edges from each node. Okay, like if the node is incoming from this node to this node, so we have to reverse them. So the reverse is like let's suppose this is 1 2 and 3, and this 2 is reverse of 1, like 2 is connected with 1. So we have to reverse their graph, and the reverse makes it easier to find terminal nodes by starting with their node and the incoming, and we have to look their idea like no incoming edges are coming from that end, so we have to reverse them. And the algorithm we have to use, first we have to use BFS, and second we have to use DFS, and third we have to use topological sort topo sort, and fourth we have to use you can also use Kahn's algorithm. So you can use many more algorithms, like only you have to find the safe node, and we have to return the sorted order. And the work we have to follow, the flow is we have a distance array or vector to store the incoming incoming edges from each node in reverse order. And the second, we have to use a adjacency vector or a matrix to store the reverse array list, sorry, adjacency list. And also then we have to reverse the values. And after reversing the value, we have one queue. We have to use a queue for processed nodes from distance of I is equal to 0. And this distance of I is equal to 0, there are nodes with no incoming edges, and after that we have to add nodes with their result, and then we have to return them into ascending order. So now let's look at their example test case. So in first example, we have to given 1 2 3 4 5 6 7 nodes we have to given here, and these nodes we have to calculate the safe node, and then we have to find their safe states. And a safe state is generally, first we have a terminal node with no outgoing edges, and the second one is another safe state. So these are two conditions for finding the safe state and safe edges, and we can simplify this by reversing the graph and reversing all edges and finding terminal nodes first. Then we have to removing connection with the process nodes. And so now let's look at their example. So the graph is 1 comma 2, and this become 2 comma 3, and this will be 5, and this will be 0, and this will be 5, and this will be empty, this will be empty. And the graph representation of this one is, we have the node 0, and this node 0 is connecting to this one node and this second node. And so node 0 is connected to 1 comma 2, and so node 1 is connected to this 2 and this 3, and this 3, 2 comma 3. And so node 3 is, so this is our node 3, and this node 3, sorry, node 2, sorry, this node 2, we have their connection with the value of 5, and so here is 5. And so node 3 is connected with 0, here 0, and node 4, this node 4 is connected with 5, and this 5 is not connected with any other node, and this 6 is no any connection. Node 5 is no any connection, node 6 is no any connection. And so here is two terminal nodes, because there are no outgoing edges from that node. So two terminal nodes here. So the node 5, first is our node 5, no outgoing edges, and the node 6 is no outgoing edges. And so this is our, you can say this is our safe state. And so now node 0 we have, so the node 0, after reversing this, so the node 0 is connected with this one. So after reversing, this 3 is connected with 0, because this 3 value, or this 3 is connected with 0, like, and then node 0 is connected with 3 after reversing. And this node 1, is connected to 0 also. And after that, sorry, so node 1 is not connected with any other nodes, like so the node 1 is not connected with any other. So this 3 is also be connected with 1, but we have to check with again. So this node 2, this node 2, we have their only self, they have not going to any other node, so that's why this is 2. And so though the node 3, this node 3 is connected to the 1 after reversing, okay. And so the node 4 is connected a self, so that's why 1. Here is also be self, okay. And here is 1. And the node 5, this node 5 is connected to 4, this 4 and this 2, so the value is 2. And so node 6 is not connected to anyone, so that's why 0. So we have to process with these values using queue, and this queue we have to start with nodes with have no incoming distance, like distance of I is equal to 0, and we have to start with their terminal. Like first we have their terminal of queue of 6 is equal to 0, because there is no outgoing edges gone through, so that's why this is our terminal node. And so now track these values by using a tracking table. So firstly we have the step and the queue and the process and their update, and after that we have to find their safe values. So here, well, step 1, 2, 3, 4, 5 and 6 and 7, and here values are, first we have to start with 6. This 6 we have to process nothing to here, and again we have to process only 6, and the updated state is 1 1 2 1 1 2 0, like here 1 1 2. This 1 1 2 is basically for how many edges are going to another node, so that's why we have to count all these values, and the safe state is 6. And here again we have to start with 5, and this is process node is 5, and then the neighbor we have to reverse, like here 5, the values, this and this 5 is generally like here is 1, and this 5 is going to 4 and 2, and so we have the values are 2 comma 4, and we have to update this one 1 1 1 1 and 0 2 and 0, like 1 2 3 4 0 2 0, and then we have to process 6 and 5, and after that we have the value of 4 and this 4, and this after reverse we have nothing to here, and is only self, and so that's why we have to know any change, and the same values are we have to got here, and the same we have to process this one, and after that we have to track and track 3. This 3 is processed with self 3, and we have no any change, and like first we have to track with 2, okay. So this 2 is to track all these values, so this 2 is the value of and 2, and so this is connected with 0 comma 1, and so here the updated values 0 0 1 1 0 2 0, and because we have to update this one, and the count minus minus, and so that's why 0 0, and the process node is 6452. And so here we have the value of 0, and this 0 becomes like the update we have to here 0 2, and this 0 is connected with like 1 second, 0 to 3, not connected, but 0 to 3, and we have here 3, and so we have to update 3 value. So 0 0 0, sorry, 0 0 1 0 0 2 0, and the value is 65420. And so again we have to track the value of 3, and here 3, here we have to process nothing, and so this remain is same. Like uh, you can say no any updated, like 3 is connected to 1, sorry, yeah, 3 is connected to 1, 3 is connected to 1, and so here is 0 here, and 1 2 3 5 and 2 comma 0, and the value is 6542 and 0 comma 3, and the last we have here 1, and this one is nothing to connect, and so that's why 0 0 0 2 comma 0, and so here 65422031, and these are our safe states. These are our safe state. Safe state is now here we have to track all these values, and now let's calculate this, and 6 and 5 we have already processed, 6 and 5, and then the value of 4, this 4 is connected with their terminal nodes, so we have also processed this, and this 3, this 3 is also, no, this 3 is not considered, and yeah, this 2 is considered because this is a terminal node for this condition, and because no outgoing edges to going here, going, so that's why 6542, and this 6542 we have to got here, and this 031, and this 0, this 0, and this 3, and this 1 is creating a loop, because this 3 is connected to 0, and this 0 is connected to 2, okay, and this this 2 is connected with another node, and this 1 is connected to again 3, so this is a loop, and this is not terminating their condition, so that's why, and so 0 and 1 is connected, and so that's why we have not processed this one, and because this is not any terminal state, and this is not our safe state, and after sort we have the value we have to get here 2 4 5 and 6, and you can also check here 2 5 2 4 5 6, 2 4 5 6, and so I hope you understand the table. So this is trickier one, like how you process the value each and every step, and after process value we have to count minus minus, and we have to update their state, and we have to find their safe state. And now let's look at their coding implementation part, so that you can understand how we can calculate each values by each position. So here first we have their node, number of node we have to derived here, and then we have their visited and their distance, and this is our visited node, and this is our distance we have to also discuss there, like this visited we have to find their this node is visited or not, and this distance is incoming edges of the count, and this adjacency of reverse the adjacency list, and then here the logic of this one is we have to reverse the edges of the graph and calculate the in degree. in degree. And here also we have to calculate the in degree. These are our degrees, like how many times they are present. And after that we have this one. We have to reverse the h and increment, and we have to increment in degree node of I, and this queue is initialized with terminal nodes of we have to queue with terminal nodes of in degree of 0, and this is our terminal. We have to check here, like if the distance of I is equal to 0, then we have to push into our queue, and directly we have to find their one value. We have directly find, like there is a terminal, then we have to find their save state. Again we have to find their save states. And now we have here process the values, process the uh, topological sort. And this topological sort is generally for the first we have to get the front node, and after this we have to add into their result, and this result we have to remove into our queue, and then this one we have to process their neighbor value. And also we have to discuss all these idea before we have to implement, and before we have to track these values. And this distance of it is decrement in degree, like when we have to process the value of neighbors, then we have their count minus minus, and you can say we have to decrement their neighbor nodes, and then we have to check here if it becomes terminal, then we have to push into queue, and then we have to sort into ascending order, and then we have to return. And now let's look at their time complexity and space complexity. So the time complexity of this code is we have to reverse the order O of E times, and then we have their topological sort of O of V plus E, and then this O of V plus E, and then we have one thing is our sorting. So sorting is O of V log V. So the total is O of V plus E plus and V log V. So this is our total time complexity, and the space complexity of this code is O of E for adjacency list, and we have their Q and their vectors. So this one is O of V. So the total space complexity of this code is O of V plus E. So I hope you understand the logic and the implementation part of this code, and their example test cases, like how we track the values. And this one is a trickier part, like how many times they have present, and we have to track the values. So thank you everyone, thank you so much.